Hi everyone. In this video, we will cover part 1 of matrices topic. We will go through introduction of matrices, matrix types, and the possible orders of matrix. What is a matrix? A matrix is a rectangular arrangement of numbers or functions. If you notice, it will be in the form of a rectangle. You have all the numbers arranged within this rectangle. Or each of these numbers are called as elements. And the way they are arranged is in the form of rows and columns. So this direction is called as horizontal and this direction is called as vertical. So now, if you look at these numbers 5 and 10, they are in the horizontal direction. So this is called as a row. 6 and 11 is another row. So 5, 10 is first row, 6, 11 is second row. Column, the vertical positioning, the vertical direction is called as a column. So 5 and 6, these two numbers are in a column. 10 and 11 is also in the column. So this is called the first column. This is called as a second column. So this kind of arrangement is called as a matrix. And it is always represented within a square bracket like this. And a name is given to the matrix. It can be anything, A, B, C, D, any name, right? That will be called as a name of the matrix. Now, for example, say Radha has 5 notebooks and 10 pens. And Joseph has 6 notebooks and 11 pens. Now, how do you represent this particular example in a matrix form? So what you will do is, you can put Radha and Joseph as 2 rows, right? And notebooks and pens as 2 columns. So Radha has 5 notebooks and 10 pens. Joseph has 6 notebooks and 11 pens. So just to reiterate, this is the row, right? This is the row and this is the column. So this is the first row, this is second row, this is the first column and this is second column. Now what is the use of matrices, right? So they are used in programming, in developing software applications, in business, in economics, in physics, in statistics. If you have to do budgeting, that is finding the budget, calculating the budget, estimating the cost, forecasting the sales, right? Multiple fields, multiple areas, matrices are used. So basically, it is used in solving linear equations, right? For example, you have a linear equation like this: 8x minus 9y is equal to 10, 3x plus 2y is equal to 5. These two are linear equations. So I have to find x and y. How can I find x and y? Using these matrices, we can find the value of x and value of y. Order of a matrix. What is the order of a matrix? It defines the number of rows and columns that a matrix has. So in a matrix, we know that there are rows and there are columns, right? Now, so in this example, we have 2 rows, 2 horizontal arrangements and 3 columns. This one, and this one. We have 3 columns. So we have 2 rows and 3 columns. So order is 2 into 3 or 2 by 3. Similarly, if you take this matrix, matrix B, you have, this is 1 row and this is 1 row. And how many columns we have? We have only 1 column. So 2 rows and 1 column. So order of the matrix is going to be 2 by 1. That is what we call here. If matrix has m rows and n columns, then order of a matrix is m by n or m into n. Now let's take this matrix C. So these are the elements. Each of these numbers are called as elements of the matrix. We assume that some element A. And how would we represent the position of this particular element? There is a position for each of this element, right? How would you say the position? So the first element is in the first row and in the first column, right? This is the first row and first column. So you'll say it as A1, 1, first row, first column. The second element would be first row and second column. This is second column. So 1, 2, 3, we have n columns, right? And you have here first row, second row, third row and m rows, right? Now second element, position of second element is first row because it's in the first row and second column. Similarly, third element is first row and third column. If you go to the second row, this element is nothing but second row. It's occurring in the second row. Its position in the second row and the first column. Next element, A22. A22 means second row, second column. A23 means second row, third column. So like this, the entire matrix, if there are m rows and n columns, then the order is m by n. So basically we represent element in a matrix as, we can call it as A, I, J. I is the row, J is the column. I is the row, J is the column. Possible orders of a matrix. If a matrix has 8 elements, what are the possible orders it can have? 8 elements. So one thing we'll have to remember, order is m into n, that is rows into columns. When you multiply rows into columns, you'll get the number of elements. So you take this example, you have 2 rows and 3 columns. So if you multiply this 2 into 3, you're going to get 6. What is 6? 6 elements are there in this matrix, right? Similarly, you take this matrix B, you have 2 rows and 1 column. So when you multiply, you're going to get 2. What is 2? 2 is the number of elements. So there are 2 elements in this matrix B, right? So now the question is, there are 8 elements. What are the possible orders it can have? Order is given by m into n, that is where m is the rows, n is the columns, right? So it is basically rows into columns. Now elements is 8 elements. That means if you multiply rows and columns, you're going to get 8 elements, right? So if a matrix can have 8 elements, right? But there are multiple ways it can have 8 elements. One is you can have 8 rows and 1 column. So you can have 1, 2, 3, 4, 5, 6, 7, 8. So you can have 8 rows and 1 column, right? So this way you can have 8 elements. Another way is you can write like this, 3, 4, 5, 6, 7, 8. Basically you have 1 row but 8 columns, right? Each of this is column, right? This is one way. So then you can also have 4 by 2, right? 8 is nothing but 4 into 2 is also 8, 2 into 4 is also 8, 8 into 1 is also 8, 1 into 8 is also 8. So we come up with all the possible combinations this way, right? We get all the possible combinations. Now when I say 4 by 2, it means 4 rows and 2 columns. So I can have something like this, 4 rows and 2 columns, like this. Or I can also have it as 2 rows and 4 columns, that is like this. 2 rows and 4 columns. 4 columns are there and 2 rows are there. So if a matrix has 8 elements, then you can have 4 possible orders. 8, 1, 1, 8, 4, 2, 2, 4. So let's take an example. If a matrix has 24 elements, what are the possible orders it can have? 24 elements. That means m into n is 24. So what are the possible combinations? You can get 24 into 1, right? Then you can get 1 into 24. Then you can get 12 into 2, 2 into 12. Then you can write it as 4 into 6, 6 into 4. Then 8 into 3, 3 into 8. So basically how many combinations we have? 1, 2, 3, 4, 5, 6, 7, 8 combinations are there. So we'll have to write it as 24, 1, 1, 24, 12, 2, 2, 12, 4, 6, 6, 4, 8, 3 and 3, 8. So these are the possible orders. Now what if it has 13 elements, right? Instead of 24, if it has 13 elements, simple. What are the possible combinations? It will just be 13 into 1 and 1 into 13. Is there anything else? Any number we multiply, we will not get 13. Only 1 and 13 will give us 13. So these are the possible orders. Possible orders are 13, 1 and 1, 13. So let's go to the next topic. We'll have to construct a 3 by 2 matrix whose elements are given by this particular expression, right? Using this expression, we'll have to construct a 3 by 2 matrix. When I say 3 by 2 matrix, it will have 3 rows and 2 columns, like this, 3 rows and 2 columns. Using this expression, we'll have to arrive at elements. We have to get all the elements. 1, 2, 3, 4, 6 elements we have to get. 3 by 2 matrix means there'll be 6 elements. 3 into 2, 6 elements. So we'll have to get 6 elements. Let's calculate. A, I, J. I is number of rows, J is column. I is row and J is column. So we'll first start with first row, right? I is 1, J is 1. Let's calculate the first element by taking first row and first column. Then we will take first row, second column, right? Then we'll repeat this. We'll take second row, first column, second row, second column. Then we'll go to third row, first column, and third row, second column. So we'll do this step by step. Now I is 1, J is 1. So we'll get A11 is equal to half of I minus 3J. I is 1 and J is 1. So we substitute I and J in this expression and we will get 1 as the element. Note that this is mod, right? This is mod symbol. Mod means in case you have a negative number, ignore that negative number and make it positive. So we have minus 2 here. So ignore minus sign here and make it as plus 2. So we get 1 as the first element. Let's find the second element. So you take first row, it is I is equal to 1, and second column, j is equal to 2. Now you substitute j as 2 and I as 1, and same thing, we'll get 5 by 2 as the second element. We repeat this for the third element, that is second row and first column, right? If we have the matrix like this, it is a 3 by 2 matrix. So A11, A12, A21, A22, and A31, A32. This is how the 3 by 2 matrix is going to be, right? So we have found out A11 and A12. Next we'll have to find A21. What is A21? That means I is 2. It's a second row and first column. So I is equal to 2, j is equal to 1. You substitute that and you'll get half. Similarly, you take I is equal to 2. You want to find this element now. I is equal to 2, j is equal to 2. So we'll get 1 as answer. Let's calculate A31 and A32. So that means A31 is I is equal to 3, j is equal to 1. So the expression we have is Aij is equal to half into I minus 3j. Now we'll put I as 3 and j as 1. So we'll get A31 half into mod of I is 3 minus 3 into j. J is 1. So what we are going to get? Half into 3 minus 3, which is 0. Right? So we are going to get 0 as the element. Now let's calculate this element, A32. A32 means I is equal to 3, I is equal to 3, and j is equal to 2. That is, A32 would be half into I is 3 minus 3 into j. J is 2. So we're going to get half into 3 minus 6. 3 minus 6 is minus 3. Now, since there is mod here, we ignore the negative sign. So it's going to be half into 3. That's nothing but 3 by 2. So this is our element. This is our last element, 3 by 2. So finally, what is the matrix? Finally, we'll have the matrix as, let's populate all the elements that we have got. We got 1, 5 by 2, 1, 5 by 2, half, and 1, and we got 0 and 3 by 2. So we have constructed 3 by 2 matrix. Now let's take another example where we have to construct a 2 by 2 matrix where the element is represented as Aij, whose elements are given by I plus j the whole square by 2, right? So each of the element has to follow this function, follow this expression. So what we will do, it's a 2 by 2 matrix. That means there are 4 elements, right? It's 2 by 2 matrix. So we'll have 4 elements. And the matrix is going to be like this. A11, A12, A21, A22, right? Now, we'll first take I is equal to 1 and j is equal to 1. We need this element, right? We need to find A11. So A11 is nothing but I plus j the whole square. 1, I is 1, j is 1, the whole square by 2. So that is nothing but 2 square by 2, which is 2. Now let's similarly find A12. We need to find A12, this one. Let's find A12. That means I is equal to 1 and j is equal to 2. So A12 would be I is 1 plus j is 2. You substitute, you're going to get 1 plus 2 is 3, 3 square by 2, which is 9 by 2. So this is our second element. Now we'll find third element. Third element is this one, A21. So A21, we'll have to find. What is A21? A21 means I is equal to 2 and j is equal to 1. So we'll get A21 is equal to I plus j the whole square. I is 2, j is 1, I plus j the whole square by 2. That is nothing but 3 square by 2, which is again 9 by 2. This is our third element. Next we'll have to find A22. We'll have to find this. A22 means I is equal to 2, j is equal to 2. So we substitute I and j. It's I plus j the whole square. So 2 plus 2 the whole square by 2, which is 4 square by 2, 16 by 2, which is 8. So the last element is 8. So what is the matrix that we have? Matrix that we have is, let's substitute each of these elements. 2, 9 by 2, 9 by 2, and 8. So this is the matrix that we have. Let's go through another topic on types of matrices. There are 9 types of matrices. One is column matrix, first one. So a matrix that has only one column is called as a column matrix. Only one column. It can have any number of rows, but the number of columns is going to be just 1. For this example, order is 3 by 1. Column is 1, right? Similarly, for a row matrix, it will only have one row. It can have any number of columns, but the number of rows is going to be only 1. The next one is null matrix or zero matrix. Very simple. If all the elements of the matrix are zeros, then that particular matrix is called as null matrix or a zero matrix. Square matrix. Square matrix means number of rows should be same as number of columns. So you have 2 rows here and 2 columns. Here you have 3 rows and 3 columns, right? So the order is 2 by 2 for this matrix, and for this matrix order is 3 by 3. So that's why it's called as square matrix. One thing to note is this particular diagonal, that is from the top left, you can call this as top left, and this is right bottom. From top left to right bottom, the elements in the diagonal order is called as principal diagonal. This direction from top left to right bottom is called as diagonal, and it's called as principal diagonal. The elements in this principal diagonal are called principal diagonal elements. So here 4 and 3 are principal diagonal elements. 1, 5, 9 are the principal diagonal elements. Now what is a rectangular matrix? In a rectangular matrix, number of rows is not equal to number of columns. Like this, you have 2 rows here and 3 columns, and here you have 3 rows and 2 columns. So order is 2 by 3, 3 by 2. If you look at this, it's different, right? Rows and columns are different for both these matrices. So this is called as a rectangular matrix. The next type of matrix is diagonal matrix. In a diagonal matrix, other than the principal diagonal elements, this is the principal diagonal, other than these elements, everything else has to be 0, right? Every other element should be 0 other than the elements in the diagonal. And one thing to note is, diagonal matrix is always a square matrix. That is, the number of rows and number of columns are going to be same. The next type of matrix is scalar matrix. In a scalar matrix, it's same thing as diagonal matrix, except that the elements in the diagonal are same, right? If you notice 2 and 2, 3 and 3, 3. So all the elements in the diagonal are same. So this type of matrix is called as scalar matrix. Identity matrix. It's also called as unit matrix. Identity matrix or unit matrix is a matrix in which the diagonal elements are 1 always, like this. So it's also called as unit matrix. The last type of matrix is equal matrices. That is, if you have 2 matrices, right, we can call them as equal if their elements are same. Now look at this. You have 2, 3, 0, 1. Here also you have 2, 3, 0, 1. So elements in both these matrices are same. So this is one condition. The other condition is the order should be same, right? Order of this matrix A is 2 by 2. And order of this matrix B is also 2 by 2. So order is same. Elements, corresponding elements. Corresponding elements means this is the first element. First element of matrix A and first element of matrix B should be same. Similarly, second element of matrix A and second element of matrix B should be same. So this is what we call as corresponding elements, right? So if you take the element here in one position, the element in the other matrix in the same position should be same. So here we can say A and B are equal matrices, or A is equal to B. Now if you look at C and D, can we say A and C are equal matrices? No, because third element is 0 here and here third element is 2. They are not same. Fourth element is also different. So even if one of the element is different, then it is not an equal matrix. And you look at this matrix D and look at matrix C. Here the order is completely different. Here it is 2 by 3 and here it is 2 by 2. So matrix A and D are not equal. Matrix A and C are not equal. Only matrix A and B are equal because the elements, the corresponding elements are same and the orders are same. With this, we have come to the end of this particular topic. Thanks for watching. Hope this video was useful.